Last class, we used the method of equivalent resistance to determine unknown parameters within a circuit. Now, what we're going to look at is a different method for determining or solving a circuit. To motivate the use of the node voltage method, let's take a look at a slightly more complicated circuit. In this circuit, we are interested in, say, determining the voltage or the potential difference that's developed across resistor R4. Using the method of equivalent resistance, we could try to determine the equivalent resistance of the entire circuit, and then from there work backwards to determine the currents and the potentials developed across each of the elements. So the first thing I'm going to ask you to do is to pause the video and ask you to identify how we can combine these resistive elements into equivalent series and parallel elements. Now that you've taken a few seconds to try to combine these elements into series or parallel equivalents, you have probably run into a few difficulties. The difficulties lie in the fact that this node and this node right here, node A and the node on the other side of R5, are connected in between the series arrangement of R1 and R2 and the series arrangement of R3 and R4. Because of this, R1 and R3 do not have the same potential difference across them. Therefore, R1 and R3 are not in parallel. And the same thing goes for R2 and R4. We cannot say that they have the same potential difference that's developed across them because of this intervening resistance element right here. So therefore, R2 and R4 cannot be claimed to be in parallel. Similarly, we cannot combine R1 and R2 or R3 and R4 in series because we have a potential location for current flow to move through this resistor R5. Therefore, R1 and R2 will not necessarily share the same current and are therefore not in series. And R3 and R4 will not necessarily share the same current, therefore they are not in series with each other either. As this example illustrates, there are certain cases where simply using the method of equivalent resistance will not allow us to completely solve the circuit. Therefore, we have to devise a different method, and in this class we're going to talk about two methods that we can use to completely solve the circuit. The first one is the node voltage method. The node voltage method is a circuit solution technique based off of Kirchhoff's current law. Now, instead of teaching you directly how to do this method and use this method to solve a circuit, what I'm going to do is I'm going to ask you to take a look at this worksheet that has been developed from your course notes. And in this worksheet, there are a bunch of examples. So for exercise 1, we have several examples. And in these examples, you are told some things about the circuit. In particular, the nodes of the circuit are identified, and these things called essential nodes and essential branches are identified. So based upon your observations of these three examples, I'm asking you to define the terms node, essential node, branch, and essential branch, and determine the numbers of equations that are required to completely solve the circuit. So prior to class, examine these examples, come up with definitions on your own for what node, essential node, branch, and essential branch means, and answer questions 1 through 4, and respond to these questions which are posted on Canvas. In class, you will be working in groups to complete this worksheet and learn more about the node voltage analysis technique.